All right, let's talk about physics. Today, we're going to put together the essential math toolbox you'll need to, well, not just survive your first physics course, but to actually crush it.
Have you ever opened a physics textbook and just your heart sinks a little? You see all those equations and feel that wave of panic? Yeah, you are so not alone. That's a super common feeling.
But here's the thing, and this is the secret, really. You don't have to be a math genius. Not at all. You just need the right tools for the job. So let's reframe this. We're not studying for some scary math test. Nope, we're building a toolbox, a practical, powerful one.
So, here's what we're putting in our toolbox. First up, signed numbers. Then, we'll get into solving formulas. After that, we'll tackle powers and scientific notation, and we'll wrap it up with a bit of geometry and trigonometry. Ready? Let's get to it.
All right, let's grab our first tool, signed numbers. See, in physics, numbers are more than just, well, numbers. They don't just tell you how much of something there is, they tell you which way it's going. You know, things like force, velocity, even temperature. That little plus or minus sign, it's packed with information.
And the best part, the rules are super simple. Seriously, if the signs are the same, just add them up and keep the sign. Easy. If the signs are different, you just find the difference, subtract them, and the answer gets the sign of whichever number was bigger to begin with. That's really it.
Okay, so why does this even matter? Let's look at a classic tug-of-war. Imagine you've got 100 pounds of force pulling to the right. We'll call that positive 100. But then you've got two forces pulling to the left. Let's say a negative 50 and a negative 30. So what do? First, combine the forces going in the same direction. Minus 50 plus minus 30 gives you minus 80. Now you just add that to your positive 100. And what do you get? A net force of plus 20. That positive sign tells you exactly which way it's going, to the right.
And you know what? Multiplying and dividing is even easier. If the signs are the same, the answer is always positive. If they're different, it's always negative. Boom! Simple as that. Okay, tool number one, it's in the box. Let's move on.
Okay, let's grab our second tool. We're going to talk about formulas. Physics is just full of them, right? But here's the key. They aren't just things you plug numbers into. They describe relationships. And this tool is all about learning how to rearrange them so you can find whatever missing piece of the puzzle you're looking for.
So there's one golden rule you have to remember. It's so simple. Think of an equation like one of those old-school balancing scales. It's perfectly level. And to keep it level, whatever you do to one side, you absolutely have to do the exact same thing to the other side. Add, subtract, multiply, whatever. You gotta keep it balanced.
Okay, so once you get that core principle, you can start using some really powerful shortcuts. And I want to show you a fantastic one I found. It's called the crossroads shortcut. And this is where things get fast. If you have a formula that looks like this, with one term on each side, you can literally just move any single part of it diagonally across the equal sign. So say you want to solve for D, just zip it diagonally up to the other side. And while you're at it, you can move A diagonally down. And just like that, one step, you've completely rearranged the formula. How cool is that?
Now, I absolutely have to share this warning from the author of the source material, Dr. Pandit. He says, don't show this crossroads approach to a math teacher. And, he's got a point. This shortcut is amazingly effective. It works every time, but it's about getting the right answer fast. It's not for, showing all your formal mathematical work. So use it wisely.
All right, tool number 3, powers and scientific notation. Think about what physics covers, the entire universe. We're talking about the ridiculously tiny mass of an electron all the way up to the mind-boggling distance between galaxies. And to handle numbers that big and that small without writing a million zeros, well, that's where exponents and scientific notation come in.
So here are the key rules you need to know. When you're multiplying, you just add the exponents. If you see a negative exponent, don't panic. It just means you flip it and stick it on the bottom of a fraction. And my personal favorite, because it's so easy to remember, anything, literally anything, to the power of 0 is just 1. And this is why we need this tool. I mean, who wants to write out 93 million with all those zeros every single time? Nobody. But 9.3 times 10 to the 7th, it's clean, it's compact, and it's so much easier to work with in your calculations. It's really the language of scale in science. Okay, it's time for the final tool in our kit. Physics is all about describing the real world around us, right? How things move,
how forces push and pull at different angles. And to do that, to speak that language, we need to understand shapes and angles. In other words, we need geometry and trigonometry.
Now don't worry, you don't need to retake a whole geometry class. You just need a handful of core facts that show up again and again. Things like, all the angles in a triangle add up to 180 degrees. Or when two lines cross, the opposite angles are always the same. Just knowing these little things can instantly unlock a problem for you.
And then, of course, there's the big one, the Pythagorean theorem. If you've got a right triangle and you know the length of two of its sides, you can always find the third. This one is just absolutely crucial. You're going to see it everywhere when you start working with vectors in physics.
Okay, I know this can look kind of intimidating at first, but trigonometry really boils down to one simple, super powerful mnemonic, SOHCAHTOA. Just remember that little phrase. It's the key to everything. It tells you the relationships between the angles and the sides. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. See, you've got this.
So let's see how these two tools, geometry and trig, work together in the real world. Say we want to find the distance x across this lake. Well, we've got a right triangle, so we can use the Pythagorean theorem for that part. Easy. Then, what if we need to find that angle, theta? We look at what we know, the adjacent side and the hypotenuse. So we use kah from SOHCAHTOA, that's cosine. Just like that, two tools, one problem, and it's solved.
And just like that, your foundational math toolbox is ready to go. It's complete. You are now officially equipped with the essential tools you need to start tackling physics problems with some real confidence.
Let's just quickly recap what we've packed. We've got sine numbers for direction. We've got formula solving to find the missing pieces. We have powers and notation to handle the huge and the tiny. And we've got geometry and trig to describe the world around us. That's a really powerful set of tools right there.
So look, the math isn't a barrier anymore. It's not the thing holding you back. It's your toolbox. And you're not just a student trying to get through a class. You're a builder. You're ready to start constructing a real understanding of how the world works. So the only question left is, your toolbox is ready. What are you going to build first?